This is GATE 2016 set 2 electrical question number 27. For the given circuit, consider the op amp to be ideal and the output voltage is V0. Then V0 in terms of V1, V2, V3 for the given circuit is being asked. 4 options are given. For NPTEL reference, you can refer to module number 4, lecture 1, Operational Amplifiers, Introduction of the NPTEL course Basic Electronics by Professor Chitralekha Mohanto, Department of ECE, IIT Guwahati. Useful data is that for an op amp, if it is ideal, then if the voltage at the one of the terminals is V2 equal to 0, then the other terminal voltage V1 will also be equal to V2, which is equal to 0. This phenomenon is known as virtual ground. The input impedance of op amp is infinity, hence no current flows into the op amp terminals. You also need to know KVL and KCL, that is Kirchhoff's voltage law and Kirchhoff's current law, which states that net voltage gain or drop in a closed loop is 0, and the KCL states the sum of net currents leaving or entering a node in a circuit is 0. So with the help of these informations, it is possible to solve this circuit and determine V0 in terms of V1, V2 and V3. So the given circuit is like this for this op amp. The out is the output voltage. Consider this node as node A and this node as node B. Then potential at node A can be determined by first determine this current, because since no current will enter into the terminals of the op amps, so this current will be 0. There is no current here, so all these currents will pass through this branch like this. So the current is V1 minus V2. In the given sense, I have assumed this sense as the current direction. So V1 minus V2, because V1 is higher than V2, then only current will flow like this. So V1 minus V2 divided by net resistance, which is 5. This is the current. And then V1 minus this drop. So V1 minus I into R. The R is 1 and I is already determined, so this is I into R, which is 1 ohm. This drop, IR drop, is subtracted from V1 to find VA. This is VA. Now similarly, by the virtual short phenomenon, VB equal to VA. This is because of virtual short or virtual ground. So VB is determined. Now we write another equation, KCL at B, that is node B. So this current will not be able to enter this terminal, so will pass through this branch like this. So V3 minus VB divided by 1, this current equal to VB minus V out divided by 9, implies VB minus V out equal to 9 V3 minus 9 VB. V out equal to 10 VB minus 9 V3. So 10 VB minus 9 V3 is V out. Now putting the value of VB, it is coming out 10 V1 minus 2 V1 plus 2 V2 minus 9 V3, which is the value of V out, which is equal to finally 8 V1 plus 2 V2 minus 9 V3. So this is the final answer, 8 V1 plus 2 V2 minus 9 V3. So option D is the correct option. Thank you.